Hello everyone, welcome to Moise. I am Gulfam and today we will be doing class 7 physics chapter 2 ICSE. So this is ICSE syllabus. Do not worry, CBSE videos for class 7 are also coming, but right now we will be dealing with ICSE physics chapter 2 for class 7. So chapter 2 is motion, and it is very important to understand what motion is, how motion works, because it is one of the most fundamental things in physics. In class 7, you will get for the first time physics along with numericals. Before, in class 5 and class 6, you wouldn't have seen numericals, but for the first time, you're getting numericals. So we will be also solving numericals along with the exercises and dealing with the question answers of this chapter. So let us begin without wasting any more time. So motion. What is motion? If I ask you a question, what is this term, motion? The chapter name itself is motion, but what is motion? Can anyone tell me? Please comment down below in the comment section. So before defining what is motion, let me define rest. Sometimes when you take rest, when you're too tired and you take rest, what you are doing basically is that you are escaping from doing some work. You are just taking a little bit of rest. You're not moving, you're stationary, kind of. So you're relaxing your body. So your movement is less than what was before. So therefore you are relaxing. Now, that is rest. The same thing applies to here. In physics also, rest is where an object does not move, in simple words. But if I define in physical terms what is rest, then I would say rest is when, suppose there is a body. This is a body, an object A. Now we all know if I place a clock over here. Suppose if I place a clock. Now what will happen is time always keeps moving. So the clock's minute hand, suppose it comes from there to here. So it will move, suppose 5 minutes. Even after 5 minutes, this object A does not move. What? It does not move. Now when that happens, when with respect to time an object does not move or change its position, we say that the object is at rest. Suppose if you keep a book on a table, what is happening is, if you do not apply any external pressure or if you do not apply any external force, you are not pushing the book, picking up the book, or you are not even touching the book, what will happen is the book will be at rest. The book is not moving. So rest is basically an object. When it doesn't move, we call that object is at rest. So now, what is motion? Motion is just the opposite of rest. Suppose, motion. Now suppose if an object is there, an object A. Now the same clock is over here. The clock is running for this one also. Now suppose there is an object A. Now after some time, suppose after 5 minutes, this object A has moved from this position to this position. So now we say that this object A is in motion. Why? Motion is nothing but change in position with respect to time. Write it down. Motion is change in position with respect to time. So anything that changes its position with respect to time means when time moves, as we all know, time will never move backward, or it will never stop, it will keep on moving forward. So when time moves forward and there is a change in position of that object, we call that object is in motion. So change in position with respect to time, I have written in the short form WRT, with respect to, you need to write in the full form. So with respect to time is called motion. I hope that's clear. So the terms motion and rest, I guess they're clear. Now, over here. Motion and rest are relative terms. What does that mean? This means that motion and rest are relative. They are not absolute. Now, what do I mean by relative and absolute? Let me give an example. Suppose if I keep a book on the table and I ask you, tell me, does the book move? Is the book in motion? You are not touching the book, you are not applying any pressure, you have just kept the book on the table. And I am asking you to tell me the book is in motion or not. What will be your answer? The obvious answer for the most of the students will be the book is at rest. I'll ask why. You will say, sir, nobody is touching the book is not moving, we are seeing with our own eyes, so the book is at rest. Now I can counter question, what about earth moving? We all know that earth is moving on its own axis, that is rotation, and it is revolving around the sun, so it is also in revolution and rotation, so it has two types of motion, and we live on earth. So can I say that if earth is in motion, I am living on earth, so I am also in motion? That's true, I can say that. And that is no gimmick. I'm not going to be I'm not tricking over here with anyone. That's absolutely true. Earth is in motion, so the table is also in motion. I'm also in motion. Now, can you tell me one single thing in the whole universe that is at proper rest? Can you? I'm waiting. Comment down below. The answer is not a single object in the whole universe is at rest. Everything is in motion. Now, what is the problem with that? The problem with that is, then what about rest? How can we define rest? If everything is in motion, then how can something be at rest? Therefore, we introduce this term relativity. Now, you don't need to know about what relativity is. Just know relative means I'm comparing something to something else. That means, suppose if you are on a train, you're moving on a train, you're traveling from one place to another, you're inside the train sitting there, the train is not moving, okay? The train where you are sitting is not moving, but suppose there's a train in front of you, just it's coming from the front side and just crossing you. So you are sitting on the window side. What will eventually happen is you will feel as if you're moving. This has happened a lot. Okay, suppose this is a train. It's not looking like a train, it's an arrow, but still, suppose. And then there is another train. Okay. This train is not moving, and suppose you are sitting over here. Now, from the window, when you will observe, if this train is moving from to the opposite direction, you will notice that as if you are moving to the forward direction. Your train has started moving. But does your train move? The answer is no. Your train does not move. Now again, suppose you're traveling in a car. Suppose you're traveling in a car. In the far distance, there are mountains, okay? There are trees. You're traveling at 30 to 40 km per hour speed, normal speed. What will you observe if you look at the mountains and trees? You will observe that they are also moving along with you. But does that really happen? Does the mountains and trees move along with you? Is it true? No, it's not true. Then why does this happen? This happens because you are sensing something. The 5 senses that you have in your body, your senses think that those are at motion or those are at rest. Why? Because we perceive by our senses, and when you are moving, In a car, when you see the objects at far distance, you feel like they are also moving along with you. And this happens because motion and rest are relative terms. This happens because of the relativity. This happens because you start comparing your car where you are sitting and comparing those mountains over there. This is the reason. Now, I won't go deep into why that happens because that is not in your syllabus. So, just like that, motion and rest are relative terms. Relative means you have to compare to define the terms. Okay? So that is very clear now. Motion and rest are relative terms. Write it down. Very important. Now, okay, so now we will be discussing on types of motion. So, motion has different kinds of type. Motion is of different types. So, there is translatory motion, rotational motion, oscillatory motion, periodic, non-periodic, uniform, non-uniform, vibratory, rectilinear, and many more. But at present, we are discussing only 9. Now, you might also ask, why not 10? Because I don't remember 10 at present. I have not even opened the book. So right now we are doing 9 types of motion. The 10th one, I don't think it's necessary. Okay, so the first 3 types of motion, that is translatory motion, rotational motion, and oscillatory motion, these 3 types are the most important. The rest ones are not that important, but the periodic, non-periodic, uniform and non-uniform, you still need to read about those. So I will not be writing on the board about each of the types, but you need to understand whatever I'm saying. Just pause the video and then write down the notes. Okay, so do not wait for me to write down on the board. So let's start with the translatory motion. What is translatory motion? If an object, suppose if an object is moving along a straight path, okay, suppose if an object is moving forward, okay, if an object is moving forward in a straight path, we call it translatory motion. What is rotational motion? Rotational motion is the type of motion you will find if a car is moving in a round path. Suppose this part. It's not perfectly round, but still. Okay. Let me make it a perfect round circle. Hopefully this time I will make it. Just take it. Okay, so suppose if a car is moving along a round path, okay, so the car is in rotational motion. Or suppose a spinning top. You might have seen a spinning top, that is kind of looks like this, I don't know, a spinning top. How does the spinning top moves? It moves at one point and it rotates. So that rotation is called rotational motion. Earth rotates on its own axis. That is rotational motion. Now, you can also take the example of a car again, but this time the wheels of the car. When a car moves, suppose if a car is moving in a straight path, we will say the car is in translational motion, but the wheels, these wheels are in rotational motion. So this is what I was talking about, rotational motion. Now, oscillatory motion. What is oscillatory motion? Suppose if I have a pendulum. A pendulum moves to and fro. To and fro means backward and forward. So if a pendulum moves to and fro, that to and fro movement is called oscillatory motion. Okay, so these 3 kinds of motion were the most important: the translatory motion, the rotational motion, and oscillatory motion. Take out your book, read these 3 types of motion as many times as you can. Try to understand deeply what they actually mean. Now, oscillatory motion. After oscillatory motion, we have periodic motion. So, what is periodic motion? Simply a type of motion which occurs at particular intervals of time, or it occurs continuously at intervals of time. So, like a pendulum. A pendulum moves from this position to this position in suppose 1 second, and from this position to this position in another 1 second. So it takes 2 seconds to move from one position to another position. Okay, so this middle position is also called as the mean position, but just leave that. So a pendulum moves from position, suppose this is the position P and this is the position Q, from P to Q in 2 seconds. Now you go to a shop and then again you come back home and again you pay attention to the pendulum. Will you find that the pendulum is now taking more than 2 seconds or less than 2 seconds? Will that happen? If the pendulum is correct and if there is no mistake in the pendulum, if there is nothing wrong in the pendulum, it will still work fine and it will still have that 2 seconds interval. So it will move to and fro in 2 seconds. Now, this kind of motion is called periodic motion. Motion happening at particular intervals of time continuously. So that is called periodic motion. What is non-periodic motion? Motion which does not happen at particular intervals of time or at proper intervals of time. That kind of motion is called non-periodic motion. Suppose, what is a non-periodic motion? Take for example football. Okay, so this is the football. Now when you kick the football, the football moves. Okay, it moves. So when the football starts moving, what will happen is eventually the football will slow down and then again you will kick, but this time it won't move that much or it won't move the same as it moved before. So that kind of motion is called non-periodic motion. Another example of non-periodic motion could be, suppose you take a rope. Take a rope, tie something heavy at one end of the rope, and then take the another end of the rope and try spinning the rope. Okay, with your hand like this. Try spinning it. What will you find is, what will you see is, what will you observe is, when you start spinning it, it gains motion, it speeds up, it gains acceleration. You don't know what is acceleration, don't worry about it. So it gains some speed, and then when you just slowly you slow it down, so it will decrease the speed or the acceleration. That is called non-periodic motion. It is not periodic, it is not happening at proper intervals of time. Now, uniform motion. Number 6. What is uniform motion? Uniform motion is the type of motion you will find in cars. If you are moving in a car, if you're traveling in a car and you are in a good nice highway, what will happen is at some point you will be moving at a continuous same speed. So suppose you are moving in a car at 40 km per hour for 1 hour. So for 1 hour you are moving in a car for 40 km per hour. That is your speed, and you maintain that speed. You do not decrease or increase that speed. That is called uniform motion. Uniform motion is the type of motion in which you maintain your speed without increase or decreasing it with respect to time. Non-uniform motion, just the opposite of uniform motion. You do not maintain proper speed. So you either accelerate or decelerate with respect to time. What is acceleration? Acceleration means sudden increase in speed. That is not a proper explanation, but right now just to make you understand, keep in mind. Now what is vibratory motion? Simply, vibratory motion is the vibrations occurring in an object. It is same as oscillatory motion when a pendulum is oscillating, but vibratory motion is happening at a very faster rate. So this vibratory motion is almost same as oscillatory motion, but this is at faster rate. So oscillatory motion happening at faster rate, or to and fro motion of an object at a faster rate of time or at faster intervals of time. Okay, so vibratory motion is, you can also say vibratory motion is the type of motion in which an object moves to and fro at lower intervals of time, very less interval of time. So that means, suppose if I have a string, okay, a guitar string. Now if I just stroke it once, what will happen? You will hear a voice and you will see the string moving very fast to and fro. that is called vibration, or the type of motion is called vibratory motion. Rectilinear motion. What is rectilinear motion? Suppose if an object is moving in a straight path without changing its direction, without changing its direction, that is called rectilinear motion. Suppose if an object is there and it is moving to this straight line only, so it is moving from one direction to another direction in a straight line, it is not bending, not going up and down anywhere, it is moving straight. So that kind of motion is called rectilinear motion. Same you will find when you are inside a car, the car is moving straight. If the car is moving straight, then that kind of motion is called rectilinear motion. Lots of motion, yeah, but you have to read them. There is no second option and there is no shortcut. I don't remember how I was in class 7. I guess it was kind of tough for me, but still, it's not that tough. If you can, if you want to do, if you have a willpower to do it, if you have a willpower to read, and if you put your interest in physics, definitely you will understand what the topic is, you will score better marks. Do not worry about that. Okay, so write it down, pause the video, write it down, please. You need to understand what is distance and displacement. These two terms are very important for you to understand right now. Our main focus will obviously be distance, not displacement, but still you need to learn both of them. So, distance and displacement. What is distance and what is displacement? You might already know what is distance. Always when we travel from one place to another, or when you are traveling, you always have to keep a record of what is the distance from one place to another. Suppose you are moving from Kolkata to Mumbai. You need to have a proper idea of what the distance is between Kolkata and Mumbai, or Pune and Mumbai. Whatever, you need to have a proper knowledge of what the distance is. But then comes displacement. Peculiar, huh? But it is almost same as distance, but there is a slight difference between them. Let me explain. Suppose this is your school. This is your school. Doesn't look like your school, but it is your school. Suppose. And this is the path you're traveling. Over here, there are some bastis and all. And then, suppose this is your house. You're traveling by van or bus, and it takes almost 1 hour to travel from your school to your house. This path, the curvy path that you see over here, this path is the total distance you're traveling from school to your home. And suppose that distance is, so distance is equals to, take for example 50 kilometers. 50 kilometers the distance, there is some traffic in the highways and all, and it takes 1 hour to reach your house. Now, suppose you have the Iron Man suit. I'm literally not joking. Suppose you have the Iron Man suit. Or you own a jet plane, which in India is illegal to ride a jet plane from school to home. Police might caught you. Police might catch you. So do not do that. But still, suppose you have an Iron Man suit and you fly totally straight. Well, let me find my scale. Where is my scale? My scale. Sorry, resume the video. Okay, suppose you travel straight from your house, from your school to your house. Straight. Now you'll understand better. Suppose you travel straight from your school to your house. Now this straight path is the displacement. So this straight path, suppose this was position A and this was B. So this straight path from AB, straight path AB will be your displacement. And suppose that displacement was 20 kilometers. Why 20 kilometers? Why not 50 kilometers? Because now you're traveling straight. You don't have to take so many turns. If you take so many turns, it will also cover more distance. Now, one thing to be clear over here is displacement is also the distance. So if you are traveling in a straight path, that straight path is the displacement, but along with the displacement, it is also the distance. You need to keep that in mind. So when there is displacement, that can be equals to distance. So displacement is always equals to distance, but distance does not always equals to displacement. Where do you find it? See over here. This is the displacement. Sorry, this is the distance. Is it the displacement? Is it equals to displacement? No. Displacement, it is not displacement. Why? Because the definition of displacement, the definition of displacement is the shortest distance from one point to another, from one point to another, or one position to another. Okay, so what is displacement? Displacement is the shortest distance from one point to another or from one position to another. So what could be the shortest distance from one point to another? It could only be a straight line. So therefore, I gave you the example of a straight line. So please write it down. Write down how all of this works and what is the meaning of all of these. Write down the definition of displacement. Pause the video and do it. Okay, so now that we are totally clear of what is distance and what is displacement, let us now discuss speed, one of the most important topics in this chapter. From this thing, speed, you're going to get lots of numericals, and believe me, you are going to do mistakes, really big mistakes. So let us discuss what is speed. It's very simple. We all know what is speed. We, especially boys, KTM fans. Please, I don't need to explain. So, what is speed? Speed is basically distance over time. This is speed. What does this mean? Basically, the total distance covered at a particular time is called speed. So what is speed? Speed is the total distance traveled by total time taken to travel that distance. That is called speed. So when you're traveling from one place to another, the total distance that you cover and the total time that it took for traveling from one place to another, that is called speed. So let me explain. Suppose you're traveling from this point to this point. This point is S and this point is R. You're traveling from this position to this position. Okay, so when you're traveling, suppose this is the distance you took, 50 kilometers. This is the distance, 50 kilometers is the distance, and the time that it took is, suppose, 2 hours. 2 hours time taken and distance is 50 kilometer. So according to the definition, what speed is? The total distance covered over total time taken. That means the speed will be what? 50 kilometer by 2 hours. Isn't it? 50 kilometer by 2 hours. Now 2 and 50 gone, 25, and this is 1. So 25 kilometer per 1 hour. Now I don't need to write this 1 hour, so that means 25 kilometer per hour. This was the speed. Now you all might have heard about this: 25 kilometer per hour, 100 kilometer per hour, riding super fast, isn't it? I know you get it. So 25 kilometer per hour is the speed. Now what was the mistake that I was talking about? The mistake was, in some problems, in some questions, you will be given, suppose 70 kilometer, okay, 70 kilometer, and the time will be given 120 minutes. What will you do? Definitely you will write 70 kilometer by 120. That is wrong. Always write properly. Either you convert kilometer to meter and minute to second, or you convert minute into hour. That will be better. So always keep this in mind. When you write something in kilometer, it's always better to write in hours. When you write something in meter, it is always better to write in seconds. Why? Because this is the SI unit, the SI unit of speed. Okay, why the SI unit of speed? I guess I forgot to tell. So the SI unit of distance is kilometer. Sorry, the SI unit of distance is meter. What is SI unit? SI unit is the internationally accepted system of units which every country follows. So therefore, the SI unit of distance, how will I find the SI unit? So suppose if I write here SI unit of speed. What will be the SI unit of speed? This doesn't look like T. So what will be the SI unit of speed? The SI unit of speed will be the SI unit of distance by SI unit of time. SI unit of distance is meter, SI unit of time is second. So SI unit of speed is meter per second. Write down this one. You might be asked in the question paper to derive this. Very important. Now always keep in mind, either you write in kilometer per hour or meter per second. Write down the note right now. Pause the video and write it down. It is very important. So if you get 120 minute, what will I do? I'll just write it in 70 by 120. That means 2 hours. So kilometer per hour, that will give me 35 kilometer per hour. Understood? So just like this, there will be many questions in your book, so solve them. Okay, pause the video and write down the notes. Okay, so there will be many such numericals and problems that we will enjoy doing over here. I will complete all of those numericals, but I will suggest you, please do not watch me doing and solving the numericals. Solve by your own and then watch the video. So this was the part 1 of the video, full of discussions. There will be part 2 of the video where I will be solving the numericals, discussing the question answers, and also discussing some more topics related to this. But right now what you need to do is go through your chapter, go through the book properly. Currently I don't have the book, that is the big problem. Otherwise I would have done the video totally complete. So let me get the book, then we'll go for the question answers and numericals. But right now what you need to do is, whatever I've taught right now, go through them again and again. Watch the video twice or thrice to understand the topic better. Okay, I will be including more graphics and more photographs and videos, but you need to pay attention. You need to pay your focus. If you do not pay your focus, if you do not pay attention, if you do not give your best, you will not understand anything, not even in physics, not in chemistry, not in biology. Studying is all about focus. The moment you start focusing, that is the moment when you will be actually studying. Otherwise, you will be just wasting your time. So, if you don't want to waste your time watching this video, watch it twice, thrice to understand the topic and write down the notes. Very important. Write down the notes and revise the notes. Noting down doesn't mean you write down in the copy once and you do not look at the copy again. It means you revise them. Okay, it means if you have done something wrong in the notes, you correct them over time. So I guess this was more than enough. So today this much is enough. In the next video we will be discussing more about it. New videos are also coming, and to let you know, if you haven't watched the video for chapter 1, it is already there in the YouTube channel. Go and watch it. And if you haven't subscribed the YouTube channel, dude, bro, brother, you are hurting me. Subscribe the YouTube channel, like the video if you loved it, and do not forget to hit the notification bell icon. Share this video with your friends, with your colleagues. It's very important because, see, as much as you share, the video gets high, we get more views, and our video is suggested to more other people. So therefore, share this video to as many people as you want. Share this video with your friends and write down the notes. I'm always saying write down the notes. Please do it. Now guys, you can also follow me on Instagram, Facebook, Twitter, all these social media platforms, and because I post lots of behind the camera videos, what goes on planning these and what goes on in my mind. Today this video, I haven't done any kind of revision and gone through the book because I don't have the book right now, and I just made the video just abruptly. So if you want to know more about me, more about the videos, more about how everything is done, the shooting and all, and more about my life, then do not forget to follow me over there. And obviously, if you follow me on other social media platforms, definitely you're going to get some more benefits. Like you will be getting some question papers to solve, I will be correcting your answers and also giving you marks based upon your answers. That will be really nice practice.